Hello! In this episode of Outboard Machining we are going to inspect a thing that my neighbor brought me in. Well, let's see. It's this. As everybody can see, it's a cylinder head. It's a cute little thing. It's not too large. Normally you wouldn't be able to lift it like this. This is from an outboard marine engine. It's 9.9 horsepower Honda, and it has all sorts of things attached to it. Normally when you deal with these things, this is over 20 years old. So as new, they were put together with nuts and bolts and everything. When they become old, they are still put together with nuts and bolts, but in addition to that, they are put together with corrosion. So it's advisable not to dismantle it too much, just the needed amount, and then let it be that way. Because it's very, even though these bolts look like good, there might be a lot of corrosion inside, and they crack really easily. So therefore it has all these exhaust pipe, for example, and all these timing gears here, and the valve mechanism, everything is in place. So there is a challenge of doing this, and what I'm going to do is to check the cylinder head straightness and to the minimum clean it up. This kind of thing, it's a milling job. So it's 99% setting up the thing, and then maybe the one last % milling. The milling can be done in seconds, minutes, and setting up might take hours. So that's always the thing with that kind of things. Furthermore, you cannot take more than probably 200ths of a millimeter out from the surface, because the geometry of this thing is really accurate. You cannot 0.1 millimeters is already too much. It's ruined if you do that. So therefore it must be put really plain. Your milling machine must be set up, trammed, nod, everything must be exactly. So this is what we are going to do now. First we are going to set up the milling machine itself, so that it's accurate for this operation. Milling, tramming and nodding, adjusting the nod and the tram of your milling machine is dependent on the model of milling machine you have. In this case it's rather simple operation. And okay, let's go on with that one. I'm going to use this thing. Sorry, my autofocus is not working at the moment. I have switched it off, so you cannot probably see this. I will. There is a special kind of dial indicator which is facing up, so it should be easy for me to. Yeah, okay. I put it there. Like that. There is my key. You don't need to tighten this like crazy, because okay. So now it's there, and now there are several things. First of all, let's take the brakes off. So several things what you need to do here. First of all, I assume that it's now about straight this way. So what I'm going to do is to put it in free gear. Yeah. So what I'm going to do is to raise the table so that it will touch this one. And now this there is this Z-axis lock, and this one actually has an impact on the table. Not in every mill, but in this mill it droops well a little bit. It impacts at this kind of distance. It impacts about 1/100 of a millimeter. So of course I want to have it knotted in a way that it is the same in when I do the actual job. And during the actual job I will have that Z-axis locked. So therefore I will lock it. And when I now get it okay. Oh yeah, and of course you need to, as you can hear, it's really clean. You need to clean everything. It must be clinically clean. So now I have raised it. I will lock it. Yeah, it had a 1/100 of a millimeter impact there. So now what I will do, I will measure it this way first and put my dial in 0. Okay, and then I will go around to here, and I already can see it's not even near. It's 6/100 of a millimeter apart, and it's 1/100 of a millimeter over. So a very gentle tap here. Okay, this is showing me 0 now, and this is showing me 0 now. Okay, now I tighten it just the tiniest amount. Okay, didn't move. Did not move. I'm keeping my eye on the did not move, and the last one, this would be a small miracle if it would move now. It's tight. Okay, and last final check for this direction. Okay, okay, it's 0. It's 0. Okay. Knotting is done. Now tramming. Since we already have the dial indicator in, it should actually here be 0. It's 100 over this side. Notice I'm using the same parallel all the way, while 100 under. Yeah. So this is now too low, so I need to knock here. Yeah, it moved. I need still to tighten that one a little bit. Oh yeah, now this is 0. And this is 0. Does it move anymore? No. Yes. Thank God. This is... oh. Where is my... This is 0. This is 0. This is 0. And this is 0. Okay, now it's the knot and tram is done. It's locked very tightly everywhere. So I'm 100% sure this is as straight as it can be. Well, now attaching this one to the milling table, it's important that you get it straight there. And well, we have to, of course, we have to measure it after attaching it to the table that it is straight. But This is the underside of the machine, of the cylinder head. Actually overside. This is cylinders would be there under or on the side or whatever orientation this is in the this side of the cylinder. So there is a machine surface here. It is my assumption that this is straight and parallel to the cylinder gasket side. So I probably could use parallels here, and then well, it's upside down now. I could then put it on the table, but there is no good place to hold it in that position, so I will use this stock to create a bar here. It's a long one and another long one, and then attach the bar to the thing with these hex bolts. So, well, let's make the bars first. Okay, well, here I'm, this is 12 by 12 millimeter hot rod steel bar, and I have hacksawed two pieces of these, and now the first task is to drill two holes through them, and now I will drill a countersink for that one. This is just a 10.5 millimeters drill. And I don't want to make this very deep. A little bit more. I think we are there. Yeah, no more. I don't want to ruin this. So, that was hole number one. There you are. Oh, that's bad. I think that's enough. Yeah. Now this is almost ready. Okay, now we test it. So let's test this thing. So now my intention is to put it like that, and it should go there. And that one should go there without bending anything. Yeah. Well. Well, I gave it a 0.5 millimeter room, and you don't want to tighten these like crazy. Again, just tighten them. It depends how we do this, but let's see. But now anyway, I will now make the other one here, and then we come back to putting it on the table. Okay, I have been mapping now around this, and what I have found out, I have tightened it to the table, as it will be when I will do the actual operation. So what I have found out here is now that this is the lowest point here, it's 0, and this one also, this around this bolt hole, it's also 0. Okay, then when we go this way, this is +5, so it's 0.05 of a millimeter up. This is 0.10 of a millimeter up, and finally up here we are 0.20 of a millimeter, so 0.2 millimeters up, and this is 0.15 of a millimeters up. So what I will do now is to place under here my shims. The shim will be office paper, this kind of stuff. I will put 2 stripes here under these and 1 stripe under this corner, and then I map it again. Well, that's what I will be doing next. Okay, ready to rock and roll. What I have done here is that I have put some neoprene rubber in the oil holes and some of the water passages, so that the chips won't go in there. Yeah. So now we will actually touch this one. Okay, now it's there. We have it. Yeah. Come back a little bit. Yeah. Yeah. Okay. We are there. So let's take as our first cut 1/100th of a millimeter. There you are. And engage the power. And then the gear. We will be using the high gear here. Of course, in the correct direction. Careful with here is these valves, so I can run this fast and then I need to advance the camshaft to take this side. So now let's go. It probably won't take almost anything, it shouldn't. This is really slow. Okay. Okay. Let's move you a little bit nearer. Like that. Okay. It almost cleaned with 1/100th of a millimeter cut. But we still have, what I'm looking at are these cylinder sealing surfaces. There is a dark spot. I would like to get rid of that. And then of course this area here, but this is only water sealings, well, in an outboard motor, water sealings, well, yeah. And there are no oil passages nearby. These are the only oil passages here in the corner, so it's probably won't hurt if this is low. We will be leaving here, I believe, some darker spots like here. It will be looking like this one after the cut I'm taking next. Now I'm advancing it 1/100th of a millimeter. Okay, this looks quite good at the moment. We have a few black spots there, but these are water sealings. Same applies to this one here. The cylinder sealing surfaces are all around clean. I made a crisscross pattern here in order to get it so that there wouldn't be any leak points, so to say. Well, I was not entirely successful. There are some, but the deviation between that point, for example, is there an angle you can see it? So it's less than 1/1000th of a millimeter less. And then next job is to unplug this thing and clean it up, and this is then ready. There is one more thing I need to do for my neighbor with this one, and it is the double pins in these holes. These are 10 millimeter pins which have an 8.5 millimeter hole and which are 16 millimeter long. This is ready. Yeah, okay, this is now ready for my friend, and I only needed to take 2/100ths of a millimeter away, and it cleaned really nicely. All the cylinder sealing surfaces are clean. I also deburred some of the holes here, which had, of course, when you do things like this, they generate a razor sharp edge, which is now no more razor sharp. And then there was also this kind of bushings. These are like 10 millimeter in diameter, outer diameter, and then they have an 8.5 millimeter hole in. So these are these are like double pins. They are put there, and they keep the gaskets on place when you assemble this thing. Okay, so that's it. In the next episode of Finogrin Machining, we are going to work with this one a little bit more. It's the next episode. So till then, see you!